Few processes in fabrication draw as much attention as automated curved panel welding. Watch as each steel panel is positioned with precision, held firmly in place by robotic arms. Advanced sensors align the edges, while the welding torch traces the curve with flawless consistency. Real-time monitoring guarantees every seam meets strict quality standards. The sparks and glowing weld beads are a striking reminder of just how much power and control are involved. As the process unfolds, it's hard not to admire the seamless fusion of metal, proof of what modern automation can accomplish. The finished curved panel is strong, clean, and ready for demanding industrial applications. Steel cutting reaches a new level with the HARVIITE solid end mill in action. This tool features a twisted cutting edge for superior corner stability, allowing smooth cuts even at steep ramping angles. Its precision-faceted eccentric relief reduces both vibration and friction, making it incredibly effective across a range of materials. Special chip gashes inside the flutes further cut down on forces and help clear chips quickly, keeping machining efficient and trouble-free. During dynamic milling, the tool tackles 4,140 steel blocks, with 5% radial engagement and impressive depths up to twice its diameter. Slotting tests push the limits, one pass at 1x diameter, then deeper and deeper until reaching a bold 2xD slot, each cut crisp and clean. Ramping and plunging capabilities are just as striking. The tool easily ramps at angles up to 45 degrees, with radial depths as high as 40% of its diameter. Even at full engagement, it maintains control and delivers accurate features. Watching these operations, you get a sense of how modern design and advanced engineering make demanding milling look almost effortless. The transformation inside a modern rail repair and welding plant is nothing short of remarkable. Used rails, battered by years of service, arrive for a complete renewal process. First, each rail is thoroughly cleaned to remove accumulated grime. Powerful presses restore their straightness, correcting every bend and twist. Precision milling and grinding machines carefully reshape the worn surfaces, returning them to optimal condition. Ultrasonic testing scans for internal flaws, ensuring safety before moving forward. Damaged sections are removed with industrial saws, while the ends are brushed clean for the next stage. Advanced welding systems fuse new and restored rails with seamless, high-strength joints. Automated weld removal equipment leaves each rail perfectly smooth. Final cuts and drilling follow strict tolerances, prepping the rails for another round of service. Seeing each step unfold highlights just how much expertise and engineering go into renewing rails that will safely guide trains for years to come. Rotor blade research at Fraunhofer IWES takes center stage as engineers build and test a small series of blades, each crafted to push the limits of material science. Production starts with laying glass fiber fabric in the mold, followed by automated resin infusion under vacuum. As the resin cures, thermal cameras monitor the process for optimal quality. A two-component adhesive is applied with a precise nozzle before the spar cap and blade halves are joined and post-cured for strength. Every detail, from the glue line to final bolted connections, is carefully controlled and validated right on the production floor. Seeing a blade emerge from the mold, structurally finished and ready for testing, really highlights how advanced manufacturing and real-time research can drive the future of wind energy. Inside the steel rolling mill at Shitty Laxmi Steel, the scale and energy are absolutely electrifying. Raw steel billets are delivered by conveyor, each one destined to become a crucial piece of infrastructure. The process begins with intense heat. Massive furnaces raise the billets to the perfect forging temperature, their surfaces glowing a bright orange. Precision timing is critical here, and the control room monitors every degree, ensuring each billet is ready for shaping. Next, automated rollers guide the hot steel through a series of stands, squeezing and elongating the metal with incredible force. It's fascinating to watch the billets transform, growing longer, thinner, and taking on their new profile as structural bars or rods. Lubrication systems keep everything running smoothly, while sensors constantly measure dimensions to maintain exact tolerances. You can almost feel the vibration in the floor as red-hot steel races through the rolling stands. Powerful shears then cut the endless bars to specific lengths, followed by a cooling bed where the steel gradually returns to room temperature. The sight of straight, glowing bars lining up on the cooling bed never gets old. There's a real sense of achievement in every batch. One of the highlights is seeing the entire process flow seamlessly, from raw billet to perfectly formed product, all within an hour. This mill can handle up to 40 tons every hour. The teamwork, technology, and sheer coordination are genuinely impressive, especially at this scale. Every piece of steel leaving the line is ready to play a vital role in construction and industry, proving that precision and consistency are the backbone of modern steel manufacturing. Every piece of Ruffoni cookware begins its journey in Italy, where tradition and precision craftsmanship define each step. The process starts with solid copper sheets, carefully measured and cut to size. Skilled artisans use powerful presses to shape the raw copper into pans and pots, their movements guided by decades of experience. Right after pressing, the freshly formed cookware bodies undergo rim machining on a precision lathe. The perfect rim is crucial for both durability and the elegant look Ruffoni is known for. Next comes the art of hammering. Craftsmen use polished mallets to create Ruffoni's signature hammered finish, each blow leaving a distinct, beautiful texture. This technique isn't just decorative, it also strengthens the metal, giving the cookware its unique durability. Lining the interior with tin or stainless steel is a key stage. The tinning process involves heating the pan and expertly spreading molten tin for a flawless, food-safe surface, while stainless steel-lined pans are assembled with the utmost care for hygiene and resilience. Every finished item is polished with great care, using a high-speed rotating wheel to gently refine the rim and surface until all imperfections are removed. Once the copper gleams with a flawless finish, the iconic Ruffoni mark is engraved, a lasting symbol of heritage and uncompromising quality. The handles are then forged from brass or cast stainless steel, thoroughly formed and attached with precision rivets, to ensure both comfort and lasting strength. Attention to detail extends to the final assembly, where lids are fitted and finishing touches are added. Each batch undergoes strict quality control, ensuring every piece meets the demanding standards of professional chefs and passionate home cooks alike. Seeing the transformation from plain copper to gleaming cookware highlights just how much skill and pride goes into every Rafoni creation. In the end, Rafoni cookware is more than just a kitchen tool. It's the result of artistry, engineering, and an enduring commitment to excellence. Each finished piece not only performs beautifully, but also carries with it the spirit of Italian culinary tradition. The journey of a gear reducer at Renxanini begins with a striking mix of scale and technology. Massive raw steel billets arrive at the factory gates, where every batch is rigorously inspected before entering a world of automation. Inside, cutting-edge CNC hobbing and grinding machines shape gear teeth with absolute accuracy, following DIN and API standards. Skilled technicians use advanced measuring systems to monitor tolerances at every step. Intense heat treatment cycles, stress relief, annealing, oil quenching, and gas case hardening build extraordinary strength into parts up to 3 meters across. Final assembly brings everything together as teams test noise levels, vibration, and load performance. Seeing these huge gear reducers come together so precisely is truly impressive. Each finished unit stands ready for demanding work in cement plants, steel mills, railways, and energy projects worldwide. Step inside Royal Metal Casting and Shinli Auto Parts, two of Taiwan's leading foundries, where the creation of iron brake drums and wheel hubs for top automotive brands is a blend of power, speed, and automation. This advanced operation begins with compensation systems and digital toolpath programming using Mastercam mill and lathe solutions. Each operation is directed by NC codes, seamlessly controlling vertical machining centers with travels of 1450-700 to 700 millimeters along X, Y, and Z axes. Vertical CNC lathes handle parts up to 800 millimeters in diameter and length, while smaller components are machined on lathes designed for diameters up to 370 millimeters and lengths up to 600 millimeters. Drilling machines add intricate features, and every finished part is checked with a Mitutoyo 3D coordinate measuring machine for accuracy. At Dapume Industrial Park, Chiayi City, production reaches new heights through two highly automated lines. Line 1 uses a German Sinto molding machine, with mold sizes of 800 by 1000 by 600 millimeters. Robotic arms handle each step, producing 30 molds per hour for castings weighing 50 to 200 kilograms. Iron is melted in a high-efficiency induction furnace, then poured into molds. Cleaning is handled by a crane-type shot blast machine, while automatic grinding machines process parts up to 100 kilograms. This line delivers up to 500 tons of castings per month on just a single shift. Line 2 features a Japanese Sinto molding machine with 450 by 550 by 400 millimeters molds built for high-speed production of lighter parts. It produces up to 200 molds per hour, handling castings from 0.1 to 25 kilograms. After molding, Parts move through an automatic cooling and shakeout line, then pass through an automatic drum-type shot blast machine for cleaning. Finishing is completed by an automatic grinding machine for parts up to 50 kilograms, averaging only 18 seconds per piece. Integrated simulation analysis and defect reporting at every stage ensure outstanding consistency and reliability. This automated system supports both speed and strict quality control, meeting the demands of global customers. What distinguishes the ThyssenKrupp CSA melt shop in Brazil is its combination of large-scale production and a highly automated, environmentally conscious steelmaking process. Everything begins with a 330-ton converter, where iron and other raw materials are charged and transformed into molten steel using advanced dynamic modeling for precise control. State-of-the-art primary and secondary dry dedusting systems work in tandem, capturing dust and emissions efficiently to maintain the cleanest environment and highest energy efficiency. The molten steel is transferred to an RH vacuum degassing unit for rapid decarbonization, followed by aluminum heating furnaces for exact heat treatment. Pre-tested 2x2 strand slab casters then shape the steel into slabs at record speeds, while automation and digital controls oversee every step. Each slab is treated with DynaGap soft reduction and DynaFlex to ensure exceptional surface quality and dimensional accuracy. Watching this scale of engineering and organization, it's clear how modern steel production combines power, precision, and environmental responsibility. Brass forging at Campras is a study in scale and efficiency. Each year, 13,000 tons of brass are shaped into millions of parts, ranging from tiny components to pieces weighing up to 6 kilograms. The process flows from mold design, cutting, and lubrication to hot forging, trimming, and sandblasting. Skilled teams handle every stage, ensuring each item meets strict standards. It's impressive to see how Campras combines advanced technology with hands-on expertise to deliver consistent quality across so many sectors. Production is already in motion as heat-treated steel parts flow onto the line, each destined to become a high-precision spherical roller bearing. Grinding starts the transformation, giving inner and outer rings the perfect faces for smooth, reliable movement. Outer rings are shaped with care, the sphere and outer diameter polished to exacting standards, while the inner ring's bore gets its own round of precision finishing. On the next stage, the inner raceway is honed and checked for an ultra-smooth surface. Cleanliness matters. Every ring is thoroughly washed and dried before assembly. Rollers, guide rings, and cages join the rings with a level of accuracy that leaves little room for error. Laser marking adds each bearing's unique identity. Grease and seals go into place for sealed models, locking in performance and protection. Before shipping, every bearing passes strict inspection, ready to support demanding machinery worldwide.